Greetings to everyone. In this video we'll be discussing about a dynamic protocol. It is open shortest path first OSPF routing protocol. So we'll discuss about this OSPF protocol in this particular video with an hands-on session. We're using packet tracer tool. We'll discuss first what is OSPF. It is open shortest path first protocol. It is one of the IP routing protocol and it is an interior gateway protocol for the internet. What is meant by the interior gateway protocol is it is found within an autonomous system. When we need to connect outside the autonomous system, we cannot use the open shortest path first protocol. Instead, we should go within some exterior gateway protocol. So now we should understand that OSPF protocol is working fine only within an autonomous system. That is why we call it as an interior gateway protocol. So OSPF is a link state routing protocol, which means that the routers will exchange the topology information within the nearest neighbors. So it will not extend beyond its neighbors. It will exchange the information only within its nearest neighbors. The topology information is flooded throughout the AS so that every router within the autonomous system has a complete picture of the topology of the autonomous system. So whatever route is there for the edge router, the information will be flooded throughout the autonomous system in the link state routing protocol. So what are the advantages and disadvantages of the link state routing protocol? The first advantage of the link state routing protocol is the complete knowledge of the topology allows routers to calculate the routes that satisfy particular criteria, which means that each router will understand about the complete topology of the network, which will be useful for traffic engineering purposes, where routes can be considered to meet particular quality of service. If I need to send a packet from one source to destination, if I can able to predict what is the cost of the route, I'll be able to satisfy my quality of service requirements. The main disadvantage of the link state routing protocol is it will not scale well as more routers are added to the routing domain. If more and more routers are getting added, in that case link state routing protocol will not work so fine. So increasing the number of routers increases the size and frequency of topology updates, and also the length of time it calculates will also get increased. Due to this lack of scalability, this link state routing protocols cannot be used for exterior gateway. So that is why we call this as an interior gateway routing protocol. Next one is what is link state advertisement. Each OSPF router will distribute the information about its local state to all other routers using an link state advertisement. It is like an hello packet. It will be sending the information for every particular interval. Each router uses the received messages to build up an identical database that describes the topology of the autonomous system. From this database, each route calculates its own routing table. So whatever information we are giving from the routers, each router will able to calculate its own routing table using an shortest path first algorithm, or it is also called as Dijkstra's algorithm. In some other video I will discuss about what is Dijkstra's algorithm, how it works. For now we should understand that Dijkstra's algorithm is an algorithm where the router will be able to calculate its own routing table based on the information given by the neighbors. So what is OSPF areas? So OSPF, we are dividing these areas into two. One is single area OSPF, other one is multiple area OSPF. If I have up to 30 routers, I can go with a single area OSPF. If I have more than 30 routers, I can go with a multiple area OSPF, wherein I can divide the area into multiple divisions, where there will be a common router called as backbone router, which will be common to both areas. Routers which will exist inside the area will flood the area information within the routing information. The router which is sharing the border with other areas are called as area border router. And here we need to know about two numbers. One is called as what is process ID. Regarding the configuration, process ID is a positive integer. It ranges between 1 to 65 535. It is locally significant. Process ID is locally significant. We can run multiple OSPF process on the same router. Process ID is only to use to differentiate between them. And one more thing, process ID need not match on all routers. It is not required that process ID should be same on all the routers, whereas area ID is important. And wildcard mask, we have already discussed about the wildcard mask in the previous videos. If you want, you can just go through the previous videos to learn about what is wildcard mask. Now we will do a small hands-on on OSPF. Open shortest path first. So you can make a note of the commands. First command is we should able to tell router OSPF process ID. As I told, this process ID is a number, positive integer between 1 to 65 535, and this process ID need not be same on all the routers. The next command is network ID. We need to give the network ID, network address, that is the address of the network which is attached to that particular router directly. Then wildcard mask of the network. Then area ID. This area ID, if it is in single area, the area ID should be same. If it is multiple area, based upon the geographical divisions, we should give the areas. If it is a single area, we can go with an area ID is 0. So up to 30 routers, we can go with the single area OSPF, even in the production networks. Here we need to add all directly connected networks in the concerned router, and we can verify it using the show commands like show IP protocols, show IP OSPF neighbor, show IP interface brief, show IP route, and show IP OSPF database. You can make a note of all these show commands and you can evaluate once your communication is done. Fine, let us move on to packet tracer tool. Hope you have taken down all these commands. Now let me take a router. I'll take a switch. I'll take a few more routers. Few more routers I have taken. I'll take some switches. And some sort of the PCs I'll take. One PC I'll take it here, other PC I'll take it. One more PC I can take it, keep it here. Now I'll connect all these devices. Let me connect all these devices. Connecting all the PCs. Those who know the connections, basic connections, they can move to the next section. They can forward the video to some extent where the connections are being done. If you want to know from beginning, you can see. Now between the routers, I'll go with the serial cables. For that, let me add the modules, turn off the router, and then add the HWIC2T cord. Turn on the router. Don't forget to turn it on. Similarly here, turn off HWIC2T. don't know whether I turned on. We'll check. Okay, then similarly I'll turn this device also on. It is on. Now I can use the serial cables to connect them. Let me label them. See, it's very important and good to label so in case of checking or verifying, no, it will be easy for you to do it. If you don't label, you will only get confused and do it. So it is better to label the IP address. It will not take much time. On this end I'll go with 10.10.10.1. here let me go with 10.10.10.2. here I'll go with 11.11.11.1. here let me go with 11.11.11.2. good. This one is serial 010. We'll label here that same thing. So 010. On this side it is again, this is also 010. 010. Then what is the ports over here? 011. 011. The other side it is 010. Okay, these are gigabit Ethernet cables only. Gig 0/0, and here again it is gig 0/0. Okay, so now let me assign the IP addresses to all devices. I'll give an IP address 192.168.1.1, then subnet mask, and I'll give this IP address as gateway as 192.168.1.100. good. Similarly here it is 2.network, so I have given the same IP address on both sides. Let me change it to 2.1, 2.2. good. Now I'll go here. Let me give an IP address for this device also, 192.168.2.1, and then the IP address of the gateway 192.168.2.100. Similarly here for this PC again I'll give the IP address 192.168.2.1. 2.2 subnet mask, and the gateway address it is 192.168.2.100. Fine. Now I need to give the IP address for the routers. So let me give the IP address for the router. It is always go and give the IP addresses with the CLI mode. Let me do the same thing. Enable conft. Here I can give the IP address interface jig 0/0. The IP address is IP address 192.168.1.100. This is the gateway address we have given. Subnet mask you can give 255.255.255.0/24 subnet mask. Then no shut is done. Similarly you can give the interface SC. What is the interface? C0/1/0. IP address 11.11.11.1. mask is /8 255.0.0.0. then no shutdown. It is done. This ends. Okay, exit from here. Similarly I can need to do it on this router as well. I'll keep this one on this side, it will be easy. No, correct. Router enable conft. Then I should give interface serial 0/1/0. then IP address 11.11.11.2 with the mask 0/0/0. then no shutdown. It is done. Similarly I'll give interface SC01 interface SC011 IP address 10.10.10.1 followed by mask, right? Then no shutdown. It is done. Next I'll give the IP addresses here. Interface jig 0/0 IP address 192.168.2.100 followed by the mask 255.255.255.0 and no shutdown. Then interface AC010 sorry 010, then IP address 10.10.10.2 followed by the mask 255.0.0. No shutdown. From this I can exit. Yes, now you can see that I have given all the IP addresses, so all the states are up. All the states are up now. So now let me do the routing. Up to this step, it is general steps which I have done all the videos. For those who are doing for the first time, also you can able to watch this video and completely do. Others can skip up to this step and you can do the OSPF. Now I need to do the OSPF. Let me start doing the OSPF here. So you can see for this router, the closely connected networks are 11 dot network is connected, and then 192.168 dot network is connected. So I'll go to this router. So the command is very simple: router OSPF and then you should give in processing ID. Processing ID can be anything as I told. So let me say that processing ID I'm taking it as 10. Then network ID is 192.168. Then 1.0. Then it's wildcard mask. What is the wildcard mask of this one? You can just think of what is the wildcard mask of this one. It is only the reverse of that. Yes, very good. It is 0.0.0.255. Correct. Then area, since it is single area, I'm giving it as area 0. That's all. So other network 11.11.11.0. What is the wildcard mask of this one? You can tell me. Calculate. Yes, it is there. 0.255. Good. Then area ID is 0. Yes, that's all. Only two networks are connected. I can end with this one. Similarly, I'll do it on the other router. Here, this router I'll do it. Here I have 11 dot network and then 10 dot network. So I need to do it for 11 dot and 10 dot network. So global configuration mode, router OSPF, and then processing IDs I can do in any ID, no problem. Network 11.11.11.0, and then mask is 0.255. No, it is not complete because I not given the area ID. Area ID is 0. Then similarly network 10.10.10.0 with wildcard mask 0.255.2. It's not complete. 0.255.255.255. Then area 0. Now it is done. Similarly, I need to do it on this router as well. So here 10 dot and then 192.168.2 dot network I need to do. So it is simple. Router OSPF, process ID I should give some ID, network 192.168.2.0 followed by the mask, it is 0.0.0.255. remember to use wildcard mask. You'll do mistakes, you'll take the subnet mask, it is wrong, area 0, and then network should go with 10.10.10.0, and then for this it is 0.255.255.255, area 0, then it is done. So we have given configured all with OSPF routing within this autonomous system. So this is my edge router which can be connected to the external network, and these are all my sub routers connected to the edge router. So let me see the connectivity between PC0 and PC2. It has failed. We'll see once again, one more packet will take. So it is successful. It is successful. So let me see the pinging also. I'll go to command prompt and I'll ping 192.168.2.1. Yes, I'm getting reply. You can see that I'm getting reply. So it is fine. Now we'll see the show commands also. We'll check once. I'll go to this router. Right now I'll show the show IP protocols. See, now we can see that the protocol OSPF with processing ID is changed. You can see that processing ID OSPF 10. Okay, similarly we'll go with the other show commands. Show IP OSPF neighbor. So you could see that we got the neighbor ID, that is the nearest one, which is the very nearest one is for this router 11.network is the neighbor network, that you could see that it is the neighbor ID. Next one, show IP route. You could see that how they are connected, whether they have connected directly connected or it is connected in a variably subnetted way. How it is connected, you can see what is this O, what is C, L, C, O, all these things you can see here. L is for local, C is for connected. All these things you could see, you could verify. So database also will verify once. So IP OSPF database, you could see that what is the link ID, what is the advertising router, what is the age of the router, and you could see all the IDs. This processing ID is 10. Router is link state with area 0. Similarly, you can verify with all other things. Now this is regarding the autonomous system. So what I am going to do now, I'm going to color this with some color. Okay. So now this is going to be my autonomous system. Autonomous system. So within this autonomous system I am able to connect. If suppose now I have a router here which is connected to, which is actually my ISP router. Let me say that I have a router. I'm calling this as an ISP router. ISP router, where I am doing the default routing on this router, where I have some servers present over here. In that case, how this information will be reached here? For example, if 2.1 network need to connect a server which is there in the ISP router, it has to reach through the edge gateway from the autonomous system. In that case, this information, where whatever route it is following to reach the ISP router, should be propagated to all the other routers. How that is done? We have a command to do that one, that we'll discuss in the upcoming video, how to connect an autonomous system with an default routing. With this, I'm closing this video. Any doubts, you can post it in comments. I'll be able to answer you. Thank you.